Welcome back, everyone. Today we're heading straight to the heart of our galaxy, the Milky Way.
Oh, cool.
Yeah. We're going to be talking about Sagittarius A,
Okay.
or Sgr A, as I guess the astronomers like to call it.
Right.
You gave me some really fascinating articles about it and the work that scientists are doing with the Event Horizon Telescope.
Yeah, it's really cutting edge stuff.
Yeah. So we're going to be talking about magnetic fields around black holes and maybe even a hidden jet.
Ooh.
Are you ready to dive in?
Absolutely. I'm excited.
Okay, so first off, the Event Horizon Telescope,
Right.
it's not actually just like a giant telescope pointed up at the sky, right?
You got it. It's actually a network of telescopes all around the world, all linked together. They combine their data to effectively create a virtual telescope the size of the Earth.
Wow, that's amazing.
Yeah.
I mean, it makes sense. You'd need something incredibly powerful to see a black hole.
Exactly.
And the EHT has already given us the first ever image of a black hole.
Right.
M87 back in 2019. Yeah.
Then our own galaxy's black hole, Sgr A, in 2022. But now they've done something even cooler.
What's that?
They've captured images of Sgr A in polarized light.
Yes.
So
Yeah.
can you explain what that means for those of us who may not have a PhD in astrophysics?
Sure. So, you know how polarized sunglasses cut down on glare?
Yeah.
By only letting certain light waves through?
Okay.
So polarized light is basically light where the waves are all vibrating in the same direction. And when light is emitted near a really strong magnetic field, like around a black hole, it becomes polarized.
Oh, interesting.
Yeah.
So astronomers can use this polarized light to actually see the magnetic fields around a black hole.
Exactly.
That's incredible.
Yeah, it is pretty cool.
So what have they found out about Sgr A's magnetic field?
Well, they found that it has these incredibly strong organized magnetic fields swirling around it, right near the edge.
Wow.
And this is the first time we've ever been able to measure magnetic fields this close to a black hole. That's amazing.
Yeah, so it's really exciting.
You know what I thought was really surprising, though? This magnetic field structure around Sgr A looks very similar to the one around M87,
Yeah.
which is over 1,000 times bigger.
Right.
So that's kind of unexpected, right?
Yeah, nobody expected that.
Yeah.
Sgr A and M87 are very different in terms of size and mass.
Yeah.
So we kind of expected the magnetic fields to be different too.
Right.
But as one of the researchers, Michi Baobuk, said, they turned out to be quite similar, which may mean that this structure is common to all black holes.
So are we seeing some kind of fundamental truth about black holes here?
Well, that's what the evidence suggests.
Yeah.
And it raises another fascinating question. What role do these magnetic fields play in the life of a black hole?
Ooh, okay, that's a good question.
We know, for example, that they're connected to those incredible jets of material blasting out from some black holes, like M87.
Ah, yeah, those jets. They're some of the most powerful phenomena in the universe, right?
Exactly. And
Yeah.
they're thought to be powered by magnetic fields
Oh, wow.
that act like giant cosmic slingshots, flinging material out at nearly the speed of light.
Wow. So since Sgr A has these powerful magnetic fields too, could it also have a jet?
It's definitely a possibility.
Well, the hidden jet, right in our own galaxy.
We haven't observed one directly yet, but the ingredients are all there.
Wow.
But, magnetic fields aren't just about launching jets.
Oh, okay.
They also play a critical role in how black holes feed.
Right, the process of accretion.
Exactly.
So, okay, let's break that down for a second.
Sure.
We've got a supermassive black hole, incredibly dense object, insane gravity,
Right.
and it's surrounded by this swirling disk of gas and dust, right?
That's the accretion disk.
Okay.
It's kind of like a cosmic whirlpool,
Okay.
swirling around the black hole.
Okay.
As material in this disk gets closer and closer to the black hole, things start to heat up.
Yeah.
Literally, friction and magnetic forces cause the material to heat up to millions of degrees.
So these magnetic fields we're talking about, they're actually shaping how the black hole consumes this material.
Exactly. They channel the flow of matter in the accretion disk,
Huh.
kind of like traffic signals directing the flow of cars.
Oh, okay, that makes sense.
As Angelo Ricart, one of the researchers, put it, polarized light teaches us a lot more about the astrophysics, the properties of the gas, and mechanisms that take place as a black hole feeds.
It's amazing how much information we can get just from studying light.
It is.
But the EHT isn't done yet, is it? What's next for black hole research?
Well, the EHT team is constantly pushing the limits.
Okay.
They're working on something called the Next Generation Event Horizon Telescope,
Okay.
or NEHT.
Okay, so like a souped up version.
Yeah.
With more telescopes and better data. What will that actually tell us?
Well, one of the most exciting things is the possibility of capturing real-time movies of black holes.
Whoa, hold on. Real-time movies of black holes?
Yeah.
How is that even possible?
Well, with the increased sensitivity and speed of the NEHT,
Right.
it will be able to capture those subtle changes happening around a black hole, even if they occur on really short timescales.
So we're going to see a black hole actually devour matter.
Potentially.
That's got to be one of the most intense shows in the universe.
It really would be.
So NEHT, but that's not the only project on the horizon, right?
Right.
I also read about something called BHEX.
Yes, the Black Hole Explorer mission.
Is that even more ambitious?
I think you could say that.
Okay, so tell me about it.
They're talking about putting telescopes in space.
Wait, so telescopes orbiting Earth?
Exactly.
Why go through all that trouble?
Because a space-based EHT would produce images that are orders of magnitude sharper
Oh, wow.
than anything we can get from the ground.
So we're talking like mind-blowingly detailed images of black holes.
Yeah, pretty much.
What could we actually see with that kind of resolution?
Well, one of the most interesting possibilities is observing something called the photon ring.
The photon ring?
Yeah.
Okay, you're going to have to explain that one.
Sure. So imagine light getting so close to a black hole that it actually gets trapped in its gravitational field.
Okay.
It circles around and around before finally escaping.
Huh.
That's the photon ring, a ring of light bent and distorted by the black hole's immense gravity.
So it's like the light's taking a joyride around a black hole before it can zoom off into space.
Yeah, you could think of it that way.
That's wild.
And the really cool thing is,
Yeah.
the size and shape of this photon ring are directly related to the black hole's mass and spin. So by studying these rings, we could get even more precise measurements of a black hole's properties.
It's amazing to think that we could one day actually see these photon rings.
It is.
Like, we're talking about features that are incredibly close to the event horizon at the point of no return.
Right.
It just makes you realize how far we've come in our understanding of black holes.
It really is remarkable.
And yet, with every new discovery, we realize there's so much more to learn. Okay, so we've covered a lot of ground here, and I'm sure our listeners' heads are spinning a bit.
Yeah, probably.
But before we get to part 3, let's take a moment to recap some of the key things we've learned. So we started by talking about the Event Horizon Telescope.
Right.
This global network of telescopes that's letting us see black holes for the first time, really.
Yeah.
And then we got into those amazing polarized light images of Sagittarius A,
Right.
revealing these intense magnetic fields swirling around it. And what really surprised me, at least, was that these magnetic fields look really similar to the ones around M87, even though that black hole's like 1,000 times bigger.
Yeah, it's crazy.
It kind of makes you wonder if all black holes have these magnetic fields.
It does.
Like, no matter their size.
It's a really interesting question.
Yeah, and we also talked about how these magnetic fields might actually be the key to understanding those powerful jets that we see shooting out of some black holes.
Exactly.
And how they influence the way black holes eat, basically.
Right.
The process of accretion.
Yeah.
But, of course, we couldn't leave out the future of black hole research. Real-time movies.
Oh, yeah.
With the NEHT.
It's going to be incredible.
And maybe even seeing those photon rings.
Yeah.
With a space-based telescope. So much cool stuff on the horizon.
I know, it's exciting.
But with all this incredible information we've talked about, I'm curious, what's the big takeaway for you?
That's a good question.
I mean, what does it all mean in the grand scheme of things?
You know, for me, it's all about pushing the boundaries of what we know about the universe, especially the most extreme environments.
Right.
I mean, black holes were these mysterious objects for so long, almost mythical, you know? And now we're actually starting to see them.
Yeah.
We're learning about their properties, how they interact with their surroundings.
Right.
All these incredible forces at play.
It really is like we're unlocking a whole new chapter.
It is.
In our understanding of the universe.
Yeah.
But I'm sure even with all these incredible discoveries, there's still so many questions left unanswered.
Absolutely.
So what are some of the mysteries that still keep you up at night?
Well, we still don't really understand how those jets are launched.
Yeah, right.
Like, how do they get started? What role do the magnetic fields play?
Yeah.
And accretion, how black holes actually feed.
Right.
That's still pretty mysterious too.
Ah.
There's a lot we don't know
Right.
about how those magnetic fields are shaping things.
Yeah. And I'm sure there are things out there
Oh, definitely.
that we haven't even thought to ask yet.
Yeah,
Like things we can't even imagine right now.
Exactly.
But that's what makes all of this so exciting, right?
Totally.
It's like this giant puzzle that we're slowly piecing together. And, we talked about the possibility of Sgr A having this hidden jet.
Right.
If it does, what impact could that have on everything around it?
Yeah.
Could we ever even see it?
That's a good question.
And who knows? What other incredible things will we discover with these next-generation telescopes?
I can't wait to find out.
It really is mind-blowing.
It is.
To think about all the things we still have to learn.
Yeah, it's amazing.
Well, on that note, I think we're going to wrap up our deep dive here
Okay.
into the magnetic mysteries of the Milky Way.
Mm-hmm.
But the exploration doesn't have to end here, right?
Definitely not.
So keep looking up.
Yeah.
Keep asking questions.
Always.
And never lose that sense of wonder.
Right.
Who knows what incredible secrets the universe might reveal.
You never know.
So, until next time.
Keep exploring.